All right. Well, let's get started here. Welcome to Applied Day 2020. It is this is the last present webinar of the day. I don't know if anybody's caught any of the earlier ones, but they were solid on Vault, iLogic, and software development containerization environment. And this seminar is using the scientific method for manufacturing analysis. And so I know it sounds like a totally lame title, but it describes to the best of my ability a good methodology and some tools and techniques that could really help out. And just so you know, tomorrow also there's three more. You can see them down at the bottom here. Electrical, what's new with Inventor, and FEA overview best practices. The FEA, I highly recommend that presentation. It's very solid. All right, let's see here. I think this presentation will go probably about a half an hour, somewhere in that range. I don't typically get too long-winded on it, but if you have any questions or whatever, shout them out whenever you'd like, and we can kind of go from there. So this is as interactive as you want it to be. So what our agenda is for this presentation. We'll go through a little bit about applied so you understand our perception or our angle that we're coming at this with. Then we'll talk about the scientific method itself and then walk through the scientific method looking against manufacturing analysis. And then at that, we'll go into some different tools, and I'll just point out some areas. I've been watching this area for many, many years. And when I come across different tools or techniques that kind of help paint the picture a little bit better, that'll help out. I always try to make note of those. And then during these Applied Day each year, I try to kind of regurgitate, if you will, a lot of the information I've learned visiting our many, many customers over the year, and try to pass that knowledge along in a manner that's everyone can gather and not have to worry about any proprietary information or anything like that. So Applied has been around since 1986. We started in Fargo, North Dakota, where I'm at today, working from my lovely home. So if you hear a dog bark or a kid scream, just please ignore it, because that's life at our house. And we started in a manufacturing company. Like I said, it was over 30 years ago. We still work with that company today, along with many, many other ones. But one of our big advantages is our team. We have a very, very strong team of engineers, well-seasoned, top-level engineers around. And the reason why we do that is our business model is to attract and retain the best engineers possible. That in itself creates a really good quality team. We pay them accordingly, benefits and everything else like any other organization. So and then we give them some variety and a good work environment, and we've got some really good engineers making some great work for our customers, and it's very fun. And pertaining to this presentation, I mean, if you talk about the scientific methodology, scientific method, that methodology is tailor-made for engineering because it's about quantifying. It's not about working a hunch. I think this, I think that. No, you have to prove it. And so that's what's nice about science, is to be able to put these numbers on it and be able to communicate effectively and accurately to others exactly what's going on, and make it completely objective. So I guess the other thing is, we're in a lot of different market spaces. So we see manufacturing from a lot of different areas, whether it's, heavy equipment, whether it's aerospace, whether it's high-speed packaging, all sorts of different markets. I think we're in 17 different market spaces. And so we see a lot of that, and you can see commonality with that. So it's pretty cool. Other than that, we're employee owned. We have multiple offices. We have over 100 engineers on staff, so it's pretty cool. It's a good company. We're doing a lot of great work. We have some really awesome customers, and so it's pretty fun. So here we go with the presentation. So most people are very familiar with the scientific method. A lot of things that are done today as far as lean, Six Sigma, all these different processes, quality programs, a lot of it has the backing, or it started with the scientific method. And so the steps of it can vary a little bit depending on whether it's 6 steps or 7 steps, or depending on your source, if you will. But they're basically all start with seeing what you have, where you're at, and then whatever question you have, what needs to happen, then you make a hypothesis about what you think would be right. Then you experiment, testing that hypothesis. Then you analyze the data. Then you draw communication or conclusions. And so it's kind of the continuous improvement. And so you're always looking at things. Once you get data, then you can make more. Then that data becomes an observation again, and then you can again go back to, all right, well, how could we do this better or that better? And then you can make assessments and do that. And the cool thing about that is, right now there was a time when it was very difficult to do a lot of testing, especially in the manufacturing environment, without completely disrupting the communication or the flow on the floor. So if you wanted to put in a different machine, or you wanted to test a different layout, different things like that, it was tough to prove that out. I mean, you could make some assumptions and different things like that, but some of these tools, and I'll talk a little bit about them. This isn't going to be a technical seminar on the tools by any means, but you can put all that information in and run some analysis and try some different variations without ever disrupting the floor. And so when you get to that, when you prove the optimized setup for your floor or what you want to accomplish, then you can say, okay, here's the data that's going to support this, and be able to go directly and tell management, hey, here's what I think we would like to do, and here's the return on investment and everything else, and all the data that people need to make a good decision. So to start, make sure. Oh, yeah, let's not hit it twice. But so the first step is observation, and so that's where are we now, right? When I go into different manufacturing organizations, over the last couple of years with Internet of Things and different things, we get down to visiting about, what are you measuring now? What's your key product indicators? Different things like that. And a lot of times things get hung up right there because it's a lot of work. It's a lot of understanding and communication that's involved to figure out just where you are at. And there's a reason why a lot of companies, they have some ideas. Maybe it's how much revenue, how many parts or units went out the door or shipped, or how many pieces the machine can make or whatever. But there's a lot to it. And in order for you to be able to quantify anything, any improvement, you have to know where you're at. So this is, I think, the biggest homework step, the biggest challenge, to just document where you're at. It's a lot of work, but it's the foundation for anything that you're going to do. What do I mean by observation? Well, what's your baseline? Do you have time studies for the different workstations? Is there a layout, that's already created? Again, what are you measuring? Some of the cool things. Oh, I got to take a drink of water. Sorry about that. So one of the cool things that we've gone into a lot of plants over the years, they're establishing a baseline as far as like their CAD floor, their layout. So a common theme that we've come into is companies like, yeah, we gotta expand capacity. We're gonna push out this wall here, or we have to move some things around because now we have to make 12 units instead of 10, whatever. And so we have to figure out how to make it all fit here. So we've gotten called numerous times to say, hey, come out here and can you look at what we have and make addendums to it or correct the model, whether it's a 2D or a 3D, just because we need to know what accurately what we have on the floor. And so because, there's some beams and pillars and stuff that can't move, but we need to be able to, get these different products around, and we just got to figure out how it's going to fit, but we don't even know where we're at right now. So in the past, if you go way back, you could verify dimensions with a tape measure. Moving on from that, you could have a laser finder or a laser, projector, so you wouldn't have to use a tape measure, but you could use a laser to kind of measure things out. Well, now it's become nearly a commodity to do a scan, a 3D scan of using lasers to do the whole plant. One of the organizations that we've been talking with, they can do about 25,000 square feet a day, and you get a whole point cloud of the whole factory, which is amazing. You don't even have to close anything down. If people are moving around or whatever, doesn't matter. You can still take the data. You get all that information. And then use different softwares to make it into a solid model, which is amazing, because then you can actually you'll have exactly what you have on the floor. And so that's one of a big accuracy improvement that's come along recently. It's not super recent. It's been around for a while, but it's becoming more mainstream, is doing the factory layout using laser scanning. And it's amazing when you get down to it, of how much better perception you can get working with a 3D model versus an old overhead layout 2D drawing. And it's helped a lot as far as in numerous ways, because you can look at mezzanines and all sorts of different other things, clearances, all sorts of different things that you couldn't see on a 2D drawing. So that's just one part of that baseline. The process of understanding the different workstations, what you're measuring, time studies, it all kind of goes together. And so flowcharts, there's just a lot there. And I'll talk about a little bit more moving forward here too, when we get into the experiment and hypothesis and analysis. I'll talk about those tools a little bit more. But just for the starting point here, an observation is there's a lot of legwork here, and quite frankly, there's not a lot of glory here. This is just work that needs to be done, but you're not going to really see massive benefits from doing it, other than that it gives you the foundation to be able to make informed decisions moving forward. And however, as with a lot of things going through this process, you are going to, it's going to become apparent many different things where you could make improvements when you start looking at it, where you're at in detail like that. So, here's another side. Yeah, so these are like some overheads. Here's a picture of a laser scan of a factory I just took off the web. As you can see, you get everything in there, then you can actually see the sizes of different workstations, a flow chart of different manufacturing processes. And then at these different stations, you can put in, the times, whether it's takt times or just different things like that, labor hours, whatever your company uses, but just to kind of get a handle on it. All right, so why does this matter? What's the big deal? We've been doing this for 20 years like this. Why do we need to do anything different? A lot of it comes into, in today's day, a big part of it is the fact that labor is tough. We're in a unique situation right now as far as the pandemic and such. However, When this is over, we're going to go back to the same situation or similar where there's just not enough labor. Whether it's using automation to take some of that out, a lot of it you can restructure, gain efficiency, productivity with different tools, whether it's hard temp tooling or a lot of different things. If you've listened to any of my other presentations over the last few years, I've gone into more smaller level items. This is kind of a holistic presentation on manufacturing engineering opportunities, but last year I did one on different smaller little bites that you can tackle. But it all boils down to organizational goals. Word comes down, oh, by the way, we're going to have 20% more product go through the floor, or hey, we're going to have to do this with 25% less labor, or we got to drive cost out of this, or whatever. But every year, everyone's challenged with different goals. And so when those goals come up, we have to figure it out. How are we going to do this? And so that's kind of a lot of times that's the catalyst of what's going on. So once you have a base, once you have the driver of what you have to do, then it's okay. What do you think? How can this what will help? Well, I need another feed line or what? So what are the variations? And this is the place where you'd want to, this is a free space for brainstorming. You could say that, I think if we had another feed line, that would work. Or, maybe if we rearranged how everything is, maybe if we had less fork truck traffic, if we get things more in a row or in a line, and, have more 2 stations here instead of 1 to help the flow because that's a bottleneck or whatever. This is the spot to identify the hunches, people's opinions, thoughts, have discussion on what those could be. What would be some things that you think would help? I mean, you're around this every day. Sometimes you get too deep into it, and you can't see the trees through the forest. But sometimes most times you have a good idea what would be beneficial. And here's where you could say, okay, this is what we're going to test for our hypothesis. The hypothesis is going to be if we had another feed line, our rate will improve by 10% or whatever. So that's kind of use the hypothesis portion of the scientific method. This is where you put in your best guess. Okay, now it's where it gets cool. Is when you're gonna now you can some of these tools that we kind of mentioned a little bit earlier of ways you can test things now without disrupting the floor. As you've been going through this whole process, the factory floor has not been disrupted. Whether you scanned it or through your time studies or whatever, everything goes on as normal there. But now is kind of a cool thing is being able to test different variations or hypotheses of what you're doing. So one tool that I've become aware of recently, and it's been around for a little while, but I just didn't know about it, but it has gotten a lot more powerful and a lot more user-friendly, if you will, is design utilities. And so it's part of the Autodesk platform. It comes with a lot of the different Autodesk products. I'm not an expert on that side of the business. Dave Elliott is the man on that side, but we were talking, Eric Miller, actually, one of our leaders, he designed a course and actually teaches a course on this. And I was in the dark on even how it worked. I was over the last year or so, I'm like, man, it would be nice if something that would do this or do that. And this answered all the questions, and it was really cool. I was like, wow, it's amazing that you could test all these different ideas, run them through and kind of refine them without having to mess around with the floor, or maybe implementing maybe not the optimized solution, or just a better piece, but you could look holistically at the whole problem. So when you're in this experiment stage, these pictures here are kind of different simulations, but here's how you could introduce a different, like a feed line or different machines or different things like that. And how it's all put together is that there's a process. I'm not sure if it's, yeah, right here. So there's different stations. So in each one of these stations is going to be a bunch of parameters about that workstation, how long it takes, what's going on, different things. And so it's kind of a flow chart. It's a process flow chart. And so then if you want to add another machine or switch to order or combine things, you can do that simulation right here without having to disrupt anything, without having to sit with 2 notebooks full of calculations to kind of figure it out. It's a visual, but you have to load up in all the information, which we would have done in the observation. First step of the scientific method would be loading all this stuff in just to capture where you're at. So now you can come back and look at this. Excuse me. Another glass of water. And now you can go back and start trying different variations with this model. Whoop, went the wrong way. So that's what we're doing here. It's a pretty nice setup, and it allows you to mess around with it. Excuse me, I have to pause here for a second to cough. Sorry about that. It's always funny how when you're talking a lot, all of a sudden you get the coughs. But oh well, don't worry, it's not the COVIDs. So my point is here, after you make your hypothesis, you make a best guess what you can do. Then you take the data that you gained in observation mode, create an experiment to try to understand how that would do, and then you can play around with, like I said, on the process side of it, what works good, what doesn't work good, and change it from there. Then after you do the experiment, you look at the data. Okay, did this help? Did it not help? Is the lines balanced now? Are we getting the throughput that we want? Different things like that. So it allows you to, and if you kind of see that in this exact, you come up with a conclusion. But again, it's kind of a circle. This doesn't exactly state it as a circle, but when you draw that conclusion, you go, okay, now I have more data, which again rolls back to the observation, back to the first step. Okay, now I know this. Now what do I think could be? What can we do here? What can we build off from this data? Create another hypothesis, do another design, collect some more data, analyze that data, draw some conclusions. And so you may find out when you go through this process, let's just say Phil, that's been at this workstation for 10 years, he thinks if he had some different tools, if I had some pneumatics or whatever, I could do this job a lot quicker. I could hit those goals. Well, you could simulate this test, you could test that theory and find out, yeah, you're right, you could, but it wouldn't result in enough of a improvement. So instead, we're going to change this whole work cell around and do that instead, because that would allow it to facilitate and grow the advancement that you want out of your goals, whatever those drivers were to satisfy those drivers. And again, like most things, once you gather some information, you learn. It's like, okay, this is a good. I've learned that I can get 60% of the way with a few of these small changes. So you might be able to say, okay, go to management and say, here's the situation, here's the data. We can improve by about 60% of our goal with these small things here that we can implement in the next month. So you could quickly get up to speed with those, get to see there's some improvement, verify your study, say, yep, that's right, or yeah, it's not quite right. But then you can go back and say, okay, Now for this last 20 or 30, 40%, this is going to be a bigger deal. So we're going to have to wait until changeover or shutdown or something like that, in the middle of the summer to change over this layout a little bit in order to gain where we need to go on the questions. Sorry, I had another drink. Crazy. We're going to have to, it's going to be a bigger deal. It's going to involve the plant shutdown to rearrange, add new machines, things like that. But in the meantime, you could prove out, well, we could make some pretty good gains with these simple things right away. But the next step is going to be some pretty significant capital expenditures. Here's the data. This is what it's going to improve on productivity or efficiency or whatever your drivers are. Here's what we'll see. Here's the investment. This is what they can present a nice, ROI to management. Or here's, we're going to have to spend 1.5 million, but we're going to see an improvement that'll be a payback in 1.5 years or 5 years or whatever numbers the data actually proves out. So then you can make an informed decision, and it's not based on someone's position in the company making a decision or someone's influence, someone being able to make a better argument than someone else on random data or no data at all. But I think this and I think that. Well, thinking's great, but you need data to prove it. So this is where it's pretty cool. And like I said, to be able to on the observation side, use some of the laser scanning that's out there now to be able to capture all that data much, much quicker than you could have in the past. And as far as forming the processes on the basic, on the observation side, being able to input that data into something like design utilities so you can leverage that when you start to do experiments and analysis to testing hypothesis. It's really, really cool. It allows you to get a really good handle and some really good control on what's happening, it's theoretically, and then you can work on the difference between theory and reality out on the floor. But that's more of a people issues. But it's really quite, it's pretty amazing actually how far it's come from over the last many years. And the last thing on the methodology side is to communicate. So once you gather all that, we talked about a little bit already on talking about ROI, get all the stakeholders together and discuss the process. And, hey, if you walk through this and you say, I use a scientific methodology or a scientific method to go through and you talk this through, this is the information I gained. Here's what we thought. This is how we tested it. This is what our analysis shown. That's just a very professional, solid way to use science to the advantage. It's not a popularity contest. It's just data. And data is what everything is built on. So pretty cool. So that's kind of what I wanted to go through here. How this applies to applied. How can this help you or how applied can help you on this? Well, we are very familiar with the tools that are used, not me specifically as far as on the user side of it, but we have experts in that area. Obviously, Eric Miller, one of our head trainer, is written the manual and the whole bit on the design utility, so that's pretty cool. So I would say he's pretty well versed on it. And we also have many manufacturing engineers on staff that could help with the observation side of it, whether it's you want us to just capture the whole observation side of it as far as do the laser scanning, the time studies, the process layout. Absolutely, we can do that. We could do all of it. We could do piecemeal of it. We could just you could use this as a guide and do it all yourself. We're good with all of it. But it's just kind of fun to be able to know that there's a way of testing and doing some analysis beyond a stack of notebooks that allows you to be able to say, hey, this is how we could do this. This is how we could rearrange this. And I know the manufacturing engineers, a lot of times it's 90% firefighting out there is just trying to keep the line moving and figuring out why this isn't working or that's not working. And so from Applied's perspective, sometimes it's easier for us to come in and kind of do these things and allow the company manufacturing engineers that are busy chasing problems, they can keep focused on that. They're going to be the experts on how to do that the best. But we could come in and do this and gather this data for you and move along and kind of get it all ready for you to do it, or we could even keep working on it all the way through the conclusion. That's your choice. It's whatever works best for you. So that's kind of that. Again, we've got the full slate of software, technology, training, and then on the services, design, manufacturing, engineering, software development, print, the whole bit. So it's pretty cool. And then if there was any questions, feel free to shoot them out. Otherwise, my email is sthompson@go-applied.com. So if anybody has any specific questions, they can certainly email me or give the office a call and they'll connect to me. Anything you want to talk about or just kick around, we're here to help. So with that, I think we're good. Another thing to mention, that I was on the factory design utilities, there's a webinar on that June 15th right here. And this is the tool that I was talking about. So if you're interested, that would be a great way to learn about what's going on. And then the last slide, this is going to wrap up Wednesday's events for Applied Day. Tomorrow, there'll be 9, 10, and 1 as far as some more webinars free of charge. So feel free to invite anybody you want to invite. These are also recorded and put up on our YouTube channel, so they can be leveraged in the future if you have questions. I know everybody's schedule's crazy, especially now. So these are all recorded so you can use them in the future. That's all I have, and I appreciate it. And that's it.